Hello everyone, welcome. Today I am going to take the MCQ series on nuclear force and Deuteron structure. It's very important topic for JKPSC physics lecturer perspective. Here we have question number 1. The saturation property of nuclear force implies binding energy per nucleon remains approximately constant for A greater than 20. You have seen the curve remains stagnant throughout after A is greater than 20, almost stagnant. And the correct option is C. You can see the explanation over here. Then again we have exchange forces in the nucleus arises due to these exchange forces in the nucleus arises due to meson exchange between nucleons. We have another question. Charge symmetry of nuclear force means force between proton is same as neutron. Which one of the following is not a consequence of charge independence of nuclear forces? Identical magnetic moments for proton and neutron. The total isospin T of the deuteron is 0. Deuteron is a bond state of proton and neutron. Its isospin singlet state with total isospin T equals to 0 and its total spin is 1. Ground state of the deuteron has, this is an important question. You can see the example, admixture of states L equals to 0 and L equals to 2. Non-zero quadruple movement of the deuteron implies its admixture. Question number 6 and 7 are relative and they were asked many times in the exams. The neutron-proton scattering at low energy shows scattering length is large and positive. Neutron-proton scattering at low energy means scattering length is large and positive. Effective range theory relates scattering length A and effective range R Y phase shift. At low energy, proton-proton scattering is less effective than neutron-proton scattering because the first option is Coulomb repulsion dominates. Second option is proton is heavier. Third option is deuteron is formed. And the fourth option is proton is unstable. It's due to Coulomb repulsion domination. We have another topic, Fermi theory of beta decay. Here are also the important questions. The first one is question number 11. In Fermi theory of beta decay, the beta spectrum is, in Fermi theory we know beta spectrum is continuous. The rate of beta decay in Fermi theory depends on nuclear matrix element and phase space. Which of the following statements is correct regarding comparative half-life log function value? The correct option is D. Lower log function means higher probability of transition. Then we have a question. Look over here. The explanation is given. Wu's experiment confirmed violation of parity in beta decay. It's an important question. Deuteron magnetic moment is approximately, there are 4 options. Deuteron magnetic moment is equal to sum of proton and neutron magnetic moments. Very easy. Deuteron has total spin 1 and even parity. This explanation is very important. Many times they asked about isospin, total spin, admixture of states, and this is what the question may be designed. Parity is not conserved in beta decay. Type of beta transitions affect the shape of beta spectrum. Maximum energy in beta decay goes to, the right option is C, shade between neutrino and electron. Antineutrino. The most likely transition in beta decay based on selection rule is del J equals to 0. No parity change. It's the most likely. Beta decay, weak interaction. Proton-proton scattering at low energy, phase shift are affected by both Coulomb and strong interaction. Total spin and isospin of deuteron. This is again a very important question. Total spin is 1 and the isospin is 0. The admixture of two states. The effective range theory is mainly applicable to low energy neutron scattering. What is the primary physical reason for nuclear force saturation? Short range and repulsive core nature is the primary reason. In beta plus decay, a proton is converted to neutron plus positron plus neutrino. Here is positron E plus positron and nu E neutrino. Wu experiment was performed on cobalt-60 nuclei.